there was a bunch of questions that I had this morning about how to do or how to solve a systems of linear equations problem. That is at the end of yesterday's lesson. Okay, so if you didn't get to it, you're not sure what to talk about, but you have to know how to do it to be able to do what we're doing today. So, we're going to go through 2 problems like that. One is 2x minus 4y equals 12, and 3x minus 12y equals 24. Okay? When you solve these, there are 2 different ways you can solve them. One way is called substitution, which you guys should know how to do. Another way is called elimination, which you might know how to do. We did do these some last year in geometry.
You got a haircut?
I did.
Did you like shear your beard?
I didn't shear my beard, but I did shave it, yes.
There we go.
Both SH words, so I see how that would be confusing. You shear sheep, not people.
Well, I mean, but like, if you shave a beard, you would expect to be gone, right? But when you shear a sheep, you don't expect all the fur to be gone.
Good point. I would call it trim.
That's the word I'm looking for.
Okay. All right. So
Let's stop talking about beards.
on this one, what I want to do is let's do the first way that I mentioned, which was substitution. Okay, you're going to want to make sure to write these down because you have to know how to do these. So by substituting, what I mean is I'm going to get one variable by itself, and I'm going to plug it into the other equation and solve. Okay, does everybody understand so far?
Oh, yeah.
Okay, so it doesn't matter what variable you solve for first, okay, but try to find one that you think is going to work out really easy. In this case, it's not probably going to matter, but I see smaller numbers in the top one, so I'm going to go with that one. Okay, but it really doesn't matter. Does that make sense?
Yeah.
Okay, so what I'm going to do is I'm going to take this top equation and I'm going to solve for x, just because I like to solve for x first. Again, it doesn't matter which variable you solve for first. So I'm going to do 2x, and I'm going to move my 4y to the other side because I know I got to get x by itself. So 2x equals 4y plus 12. Everybody with me so far?
What about the
I moved it to the other side since this went from the left side to the right side. I had to add it to both sides. Did that answer that question?
Yeah.
Okay. So now I'm here. To get x by itself, I need to divide everything by 2. So I get x equals 2y plus 6. You know, obviously that's not an answer, because I'm going to get a whole number here, or not necessarily a whole number, but I am going to get a number, not an expression. Okay? But since this is what x must equal in terms of y, I can take this and plug it in here for x, and then I'm going to have a y instead of an x, and I'm going to have a y here, so I'm really only going to have one variable now, right? Okay? So I take this, and I'll do this off to this side, so I have 3 times, but instead of x, I have 2y plus 6. And then I have minus 12y equals 24. Now I just have to finish it out and solve for y. So 3 times 2 is 6y plus 6 minus 12y equals 24.
that should be.
Wait, why?
That should be.
Thank you very much. That should be 18. It's like, why is everybody yelling at me? Okay, so we're good there. And then combine my like terms. 6 and negative 12 is?
Negative 6.
Negative 6y plus 18 equals 24. How do I move this over? Subtract. I get negative 6y equals 6. So y equals negative 1. Okay. Decent amount of work for one variable. Okay, but now that I know what y is, I should be able to plug it in anywhere I want and get what x is. You can plug it in here, you can plug it in here, or you can take the easy route, just already solve for x, and you can plug it in right here. That's where I would do it. Okay? So I plug in negative 1, x equals 2 times negative 1 plus 6. So x equals
4.
positive 4. Okay. So I found an x and a y. What is that though? What are we actually solving for? Does anybody know? We're solving for an ordered pair, a coordinate of where this line intersects the other line. So my coordinate would be 4, negative 1. Okay, so that's what we're solving for. We're finding a coordinate where the two lines cross. Okay. Okay. Substitution. You should know how to do that one, because all you're doing is getting a variable by itself and plugging it back in. The next one I want to do is called elimination. And on your assignments, you're going to want to know how to do this because it will make what we're going to do today and tomorrow much easier. So let's do that one I have over there. I have 8x plus 3y equals 24. And x plus 6y equals 12. Okay. What's eliminate mean?
Get rid of.
To get rid of, right? We are going to eliminate one of these variables. It does not matter which one, okay? But to eliminate them, what we are going to end up doing is taking the two equations and adding them together. You guys remember doing this a little bit?
Just from this morning.
Okay. Oh yeah, you were in here this one. Okay, we're going to add them together. Okay? But to be able to eliminate a variable by addition, if one of them is positive, the other's got to be negative, because a positive 2 plus a negative 2 is 0, right?
Mm-hmm.
Okay, they cancel out. But the numbers also have to be the same. Okay? So if this is a positive 8, and I want to eliminate x, this has to be a negative 8. You can only make things bigger, don't ever divide. So since this is a positive 6y, I could change this to a negative 6y. And that's what I would want to change it to. You just got to find a multiplier to make it happen. Go ahead.
What?
You lost.
Agree or disagree? Negative 6x plus a positive 6x is 0.
Yes, okay.
Goes away.
Yes.
Okay?
That was
So
right, right? Okay.
what we're going to do is, since this is a positive 8x, I'm going to change this into a negative 8x. Okay?
So you have to
But if I
multiply
do it to this, I got to change it to everything, otherwise I'd be altering.
But you don't do the top equation.
Right, the top one's good. Now, if I decided to do the y's, I wouldn't change the bottom, I'd change the top, so this would be a negative 6y. Okay? So, let's change this to negative 8. So I have to take this entire equation and multiply it by negative 8, because that's what would make it opposite of my top x. Okay? Negative 8 times x would be negative 8x minus negative, or it's plus, but negative 8 times 6 is negative 48y equals negative 8 times 12,
Negative 4. 96.
negative 96. Okay? So all I did there is I changed the bottom equation so that it was exact opposite with this x. Okay? So now I'm going to take this top one, I'm going to rewrite it. So I have 8x plus 3y equals 24. Okay? So now I don't need those top two anymore. I'm done. I changed it so I can get rid of my x value. So we go ahead and we add these. Those cancel because negative 8 plus 8 is nothing. Right? Negative 48 plus 3.
Negative 45.
Negative 45y equals negative 96 plus 24.
Negative
72.
Negative 72. Immediately I notice, so I don't even have to mess with them, I see two negatives, and I know I'm going to divide, right? So it's going to end up positive, so let's not worry about those. But then I need to divide by 45. So I have y equals, well, what goes into both 72 and 45? 9, which will give me 8 over
5.
5. Okay. So there I have my y value. Yes, Peyton?
Why can you just change that one equation and not have to do anything to the other equation?
Because they are separate equations.
Okay.
Now, all I'm doing, and I'm not changing it,
Okay.
I'm writing in a different way. Because since I multiplied negative 8 times everything, I could divide it by negative 8 and it'd go right back to the same thing. So it's actually the same thing, but I just multiplied it and changed the numbers. The ratios are all still the same.
Okay.
Does that make sense?
Yeah, that makes sense.
So if I 1 to 6 to 12, right?
Mm-hmm.
It'd be the same way. Or excuse me, it'd
Okay.
be here. 1 to 6 to 12. That'd be the same ratio if I reduced them.
That makes sense.
Okay? Abby?
Can you do the second part of it again? Like the after you take the 8x, after that cancels out,
After that canceled out, I took negative 48 plus 3,
right?
and I took negative 96 plus 24. That gave me 45y equals 72.
Okay.
Now I just have a linear equation. It was negative 45. Y equals negative 72. Divide by negative 45
Why do you divide?
to get y by itself. It's just
Oh,
an equation.
okay, sorry. Okay, no, we're
Good?
good now. I'm really sorry.
Sorry, not sorry?
Well,
Okay, so now I have y. Now I can take my y value and I can plug it in anywhere I want and solve for x. I can plug it into my very first one, my second one, or I could plug it into the one that I changed. Okay? Go for the stuff that's easy, right? I know that y is 8/5. Well, I see this second one here. There's nothing with the x. I would not have to divide, right?
Yeah.
So let's do that one. I take
Yeah.
x plus 6 times 8/5. I just plugged in for y equals 12. So I have x plus 6 times 8 is
48.
48 over 5 equals, I need a denominator of 5 on this 12, right? So I multiplied, it used to be a 1, I multiplied by 5,
So it would be 6.
so it's going to be 60 over 5,
wait.
okay?
Never mind.
All I did is find a common denominator
Yeah.
of 5, so because I knew I was going to have to subtract.
So we just change things however we want to make our problems work?
Basically.
No. These are all, guys, finding a
Logical, yeah.
common denominator to subtract fractions is
Changing it.
like 7th grade math.
Well, sorry.
Because that's why I struggled in 7th grade, because I hated fractions.
Me too.
Okay, so 60 minus 48, because I'm going to subtract 48/5, is 12 over 5. So the coordinate where these two lines would intersect would be 12/5, comma 8/5.
Where'd you get this from?
This is absolutely stupid.
Stop.
When
You're
you
causing a scene. I got 12/5 because I took, and I had to subtract 48/5 on both sides to get the x by itself.
Gotcha.
Oh,
So I took 60
yeah.
minus 48.
Gotcha.
Okay.
That's why I also changed this to 60 over 5,
Make it a
because I
lot
saw
easier.
that coming. I knew I was going to have to find a common denominator.
Which way do you think
I like substitution better.
Most of you are going to say substitution, but when I show you what we have to do today, it won't work all the time.
Dang.
I hate
It will
that.
not
That's
always
what
be
I
the
like.
easiest.
so you'd rather
Because I'll show you in a little while. Yes, Olivia. Okay, what I want you guys to do is I want you to go in your journals to exploration number 2. it gives you 3 linear equations, or systems of linear equations. I want you to solve one of them using substitution, and I want you to try to solve the other 2 using elimination. Okay, let me know if you have questions. I will come help you. 1.4, yes. Now it's playing? Okay. I don't know those exact answers, but a lot of you were getting them. Just be aware, guys, the hard part with these is if you make one negative sign mistake, the whole problem's wrong. You gotta start over. You know what I mean? Lainey saw it. When she distributed -2, she missed a negative sign on the end, and the whole thing ended up wrong. Okay? You have to be very careful and very precise with what you're doing. Okay? Do not go through these problems quickly. You want to take your time on these. What I want you to do is go ahead and put your journals away. I promise you we'll have plenty of time to practice this. What we are doing today, what we were doing, was we were solving systems of linear equations in 2 variables, x and y. Today, we're solving systems of linear equations in 3 variables. Z. So, we were doing ax plus by equals c. Now we are going to be doing ax plus by plus cz equals d. Okay. Now, the difference here, obviously we have 3 variables. When I get an answer, it used to be an ordered pair, right?
Yeah.
Now it is going to be an ordered triple. Okay? What this is, it's your 3rd axis. You have your x up and down. You have your, sorry, that was backwards. You have your x left and right. You have your y up and down. And you have your z, which is forward and backwards. It's making it 3-dimensional. Okay? It's okay. Okay? It is still a point right now. With what we're doing today, it's still a point that we're going to get. Okay? The solution will be an ordered triple. You guys can see an example there on page 30 of what these are going to look like. Does everybody see that? Right in the middle of all the vocab. Okay, that's what it's going to look like for us. So, what we are going to do is we're going to solve one of these. We're going to solve example 1 together. I am going to do the one in the book, but I don't want you to follow it because it's sometimes hard to follow here. Okay, I want you to follow what we are doing in class, take very good notes, and ask questions if you have them. Okay? They're going to be long. I made a comment to you at the beginning of the school year that we will have problems that take a full page. That's these. Okay? So, just understand they're going to be long. Just stay with me. If you have questions, let me know. I will try to color code things up here as good as possible. It'll actually be easier for you on paper because you won't have to scroll up and down like I will. Okay? But just take good notes. So, what we're going to start with is 4x
We need a fresh sheet here.
plus 2y, yeah, I started on a fresh sheet of paper, plus 3z equals 12, 2x minus 3y plus 5z equals -7, and 6x minus y
Oh wait, there's more.
plus 4z equals -3. Okay, and I am going to label these so we are all on the same page. This is equation 1, 2, and 3. This is what I'm talking about when I say substitution can get difficult. Okay, there are problems like this where substitution could be easier. Okay, most of them I would suggest that you just go ahead and work with elimination. Okay, So we'll go through that process first. Step 1. Pick 2 equations, eliminate 1 variable. Okay? Now I'm going to tell you step 2 also, that way you can kind of look forward because sometimes that determines which equations you pick. Step 2, you're going to pick 2 different equations and eliminate the same variable. Okay, the reason I tell you that is because if I look over here, 3, 5, and 4, it's going to take a pretty big number to eliminate them all, right? It's going to take, can't even think of it off the top of my head. Okay? But it's going to take something that's divisible by 5, 4, and 3 all at the same time. Okay? So we probably don't want to mess with that one. We'll leave that one alone. Okay? I could get 6, 2, and 4 to
24.
12.
Ooh.
Okay? Or I look here in the middle. Anytime you have a variable by itself, that's probably the one you're going to want to go with. I could get a 1, 3, and a 2. I could get all those to 6 pretty easy. Okay? So I'm going to do that one because I think that's going to give me the smallest numbers to work with. Yes.
So we're eliminating y.
We're going to eliminate y on this one. It doesn't matter which variable you eliminate first.
Okay.
Just try to find which one you think will be the easiest. Typically, if there is one that does not have anything except for a 1 or a negative 1, that's probably going to be the easy one. Usually. Not always. Okay? So, let's just take 1 and 2. Okay, because that's actually going to be the hardest one, because I'm going to have to change both of them to get to 6. Okay, so I'm going to take equation number 1, and I need to change that 2 into a 6. So I need to multiply everything by what? 3. 4 times 3 is? Right, 12x. I know that this is going to be 6y. 3 times 3 is? 9z. 3 times 12 is 36. Okay. I need to change this into a negative 6. Okay. But it's already negative, which is good because otherwise they weren't going to cancel, right? Okay. So I need to multiply 3 times 2. So I need to take the whole second equation and multiply it by 2. So 2 times 2 is?
4.
So I have 4x minus 6y plus 10z
Negative 14.
equals negative 14. Okay? So that basically is the same steps that we just talked about on the elimination method just a minute ago, right?
Yeah.
Okay. Now, go ahead and add these 2 equations together. 12 plus 4 is 16x. Positive 6 and negative 6? Cancels. That was the whole point of everything we just did,
Yes.
right? Was to make that happen.
Yes.
9z plus 10z.
19z.
36 plus a negative 14. Positive 22. Okay. Now what I want you to do on your paper is put a box around that.
Oh.
That's not an answer, but we will come back and we will use that again in a little bit.
I'm confused. Can we go up for a sec?
Yep. I took equation 1, multiplied it by 3 to get that to 6. Equation 2, multiplied it by 2 to get that to negative 6. And then I added my like terms. Okay. Now I'm going to go take 2 different. Yep.
Does it matter which 2 equations you use?
No, it does not. Now I'm going to go take 2 different equations and do it again.
But what about the same variable?
With the same variable, yes.
What do you mean? Like y?
Meaning the next 2 equations I pick, I got to get rid of y again.
Okay.
Okay? I'm going to pick 1 and 3 because one's positive and one's negative already. Okay? If I'd have done these 2, that'd be fine, but I'd had to multiply one of them by a negative number. Is everybody with me while I'm doing that?
Yeah.
Okay, you'll catch on with some tricks. Okay? So I said I'm going to do 1 and 3. So number 1, well, first of all, if I use number 3, I can easily change that into a negative 2. So I don't have to change the first equation at all.
Oh.
right?
Yeah.
Does everybody see what I'm looking at?
Yeah.
I can change this into the opposite of this. So I don't need to change this equation. Okay, so I have 4x plus 2y plus 3z equals 12. Okay, that's equation number 1. Now, to use number 3,
Times 2.
I'm going to have to double everything because if this is a positive 2y, I need this to be a negative 2y to cancel.
Correct.
Right?
Yes.
So I have 2 times 6 is
12x.
12x minus 2y. 4 times 2?
8z.
8z. And 2 times negative 3 is?
Negative 6.
Negative 6. Okay, so I did the same thing I did on the first one. I just made my y's so they were opposite so I could cancel them out. Okay, so we're still doing our elimination. And now I add. 4 plus 12. 16x. 2 plus a negative 2? Cancels. 3z plus 8. 11z. 12 plus a negative 6.
6.
Positive 6. Put a box around that. You need that. Now, what I'm going to do now is I'm going to rewrite what I have here. 6x plus
16x.
Yeah, it's 16.
thank you,
Yep.
equals 22.
Yep.
And then I have 16x
Plus 11z equals 6.
Forget about everything we've done to this point. What does that look like? Looks like exactly what we were just doing a little bit ago, right?
Yeah.
It just instead of a y, it's a z. But that's a system of linear equations in 2 variables.
Yeah.
Okay? So now we did all that work. Now we're back to a point that we're familiar with.
Correct.
So you were just working with. Now we're going to do it again. Okay? Olivia?
Why do you have to combine like only 2 equations? Why don't they like all combine? Like 1 and 2 are together, and then like 1 and 3 are together. Like why aren't 2 and 3 together?
They could be if you wanted them to be. You could do 2
so
and 3.
It doesn't matter.
It does not matter. But what you don't want to do is you don't want to do 1 and 2, eliminate y, and then come down here and do 1 and 2 again. Don't do that. Okay? If you do 1 and 2, you either got to do 1 and 3 or 2 and 3. Because you're going to have to use all 3 equations at some point in that. Notice I used 1, 2, and 3. You'll use all 3 of them on that first step. Okay?
Is this the first step?
Yeah, I eliminated y. That was
Okay.
step 1.
How many steps?
Enough. Okay, y is gone, so I don't have to worry about y for a little while. Now I'm down here with x and z. Okay, I'm going to do the exact same thing we did just a little bit ago. Okay, if you look at this, do you see something that might easily get eliminated?
16x.
That's 16. Only issue is what?
You need to make one of them a negative.
They're both positive, right?
Did you multiply by
Okay.
-1?
So all I'm going to do is take a -1, and I'm going to do it to the bottom one. That
Yeah.
way I can take 22 plus a -6 and not get a negative over there.
Yeah.
It doesn't matter though, you get the same answer. So I'm going to change that to a negative, that to a negative, and that to a negative. That's the same as multiplying by -1, right?
Mm-hmm.
Okay? Now, add.
And now,
16 plus -16
cancel.
cancels. 19 plus a -11.
8.
8z
Oh, Z.
equals 22 minus 6.
16.
16. Oh, look at that. What's z equal?
2.
Box it. You need it.
That is 1 out of 3.
We are 1/3 of the way there.
Oh.
Good news is it goes really fast. from
It's,
here,
yeah.
Okay?
Woo!
So, now that I already know what z is, I'm going to take one of these two equations and figure out what x is. Okay, so I'm going to go back. I'm going to use the 16x plus 11z, which is now 2 equals 6. Go ahead, Peyton, what I was.
Yeah.
What did we just do? We got the second.
Okay, I just found my z.
Yep.
I went
Weird.
back to here,
Mm-hmm.
and I took this equation. I just took the negatives back out of it.
Oh.
Because you're only looking for your x.
That makes sense.
Just
thought you
because
just, like,
I just switched, because we made them all negative,
Mm-hmm.
it's going to be easier to work with positive numbers. So I took all the negatives back out.
How's it going over there, Miranda?
Okay, so I have 16x plus 22 equals 6. That's just one variable. We should be able to solve this pretty easy.
Yes.
Subtract 22. 16x equals
Negative 16.
negative.
16. Are you sure?
Yes.
Yes. We did it earlier.
It definitely is. Okay.
Divide by 16. X equals negative 1. Good. We got that. Okay, we need that. So keep it.
Yeet.
Okay. Now I have 2 out of 3. So I can now I go clear back to the beginning,
Perfect.
and I got to figure out what y is now, right?
You just gotta plug it together
Now,
too.
which one looks like the easiest one?
The
Always
top
go,
one.
Always go for ease.
The top.
bottom.
The top.
One.
There's
I
no
think-
negatives on the top.
Okay.
1.
So I guess it depends. Who thinks 1? Do it. Go.
Ah, jeez. Which one are you doing, Mr. Sutter?
I'm gonna do. Who's doing 2?
I'll do it.
Who's doing 3?
I was thinking
Go.
Okay.
Oh.
I
Whatever.
forgot my answers. What was X?
I know, I forgot that
X
too.
is
Negative
negative
1.
1 and Z is 2.
Oh god.
16x equals negative 16.
I bet I did it wrong. Oh, bro. What do I do?
I did it so wrong.
Okay, so as long as on
I did it really wrong.
I
Okay.
don't completely forget how to do all of this, we'll be fine.
Oh my god.
Oh,
Is that positive?
Yep, sorry. Just gonna put 5 in. Man, what I did there.
I found mine. I got 17 over 3.
Hey. Negative 4 minus
Yeah, I have
6.
some extra numbers.
To 10. Yeah.
Did you get 17? What did you get? 5. God dang it.
Positive.
Y equals 5?
Okay. All right, guys. Let's
Oh
go
my
over this.
God.
I got most of you. Y equals 5, right? So real quick, the answer: negative 1, 5, 2, ordered triple. Okay.
Homework?
I want you to try 1 through 7 odds.
Okay.
Please.
Or
On mine, I put it on there. Okay, it's only the odds there for you. So try to get through number 7. If you don't, if you get stuck, let me know. That's okay. We'll work on this more tomorrow. We'll move on and do a couple more examples.